Okay, so we've gone through developing a little bit about our massing model, getting context together, beginning to get some environmental analysis done at the pre-design level, and now we need to start looking at using FormIt to fabricate our site. So again, we've got this little project right here, this small building right here that we've been working with, and let's look at sending this guy from FormIt to a 3D printer. So the first step is I want to export this by itself. And now when you're using a 3D printer, you can certainly take a small group like this and send it as a block. But I typically don't advise, especially while you're learning 3D printing, not to try and send an entire city block or something at that scale all at the same time. It's not going to print any faster because it's the same amount of material, same amount of height, same amount of layering that we're trying to do. And if one fails, if this print fails, if I'm trying to print all three of these together, if this fails, this is going to fail as well in terms of printing. And if you've done any 3D printing at all, failure is really just part of working with the system. So what we're going to do is isolate this object, send it to two different 3D printers, or at least look at the two different software interfaces for the two different 3D printers, and then look at a little bit of the results and fire a few warning shots in terms of what 3D printing is going to do. So let's go ahead and select this object inside of FormIt. I'm going to come down to my Save As, or my Export actually, and I'm going to export just this piece locally. Again, Save As is going to give me everything. I want to export this as an STL, or a stereolithography file type. So I'm going to go Export locally, and notice I have this set to STL, selected only, and I'm going to set, again, my street address for the building. That's one of the better naming conventions for working, in my opinion, on these larger urban context models. So this is going to be 828 Main Street. And I'm exporting this locally, so it's going to save it to my computer's hard drive. And export. And we're just going to go to More Apps right here. It's asking what do I want to open this in. And we are going to open it in, well, I'd like to open it in MakerBot. The MakerBot software, there we go. Okay. So it's immediately going to import that file, that STL file, 828 Main Street, into my MakerBot software. Now, if you notice, the first thing it's done is it's actually fitting inside of the build plate, which is kind of funny because if you remember, this dimension right here is 50 feet. But inside of FormIt, 50 feet, if you think about the Cartesian coordinate system, 50 feet is going to be defined as a number 50. And inside of Makerware, this dimension right here, 50 feet, the 50 is going to be defined as 50 centimeters. So if we look at the scale of this object, we should see something close to that 50, or not centimeters, excuse me, 50 millimeters. So we should see something that's close to that 50 millimeters in this direction. So we've already had this weird conversion that's happened, going from feet to millimeters. And now I need to get this to the scale that I actually want my model to be at, which is 1 to 60. So again, I've got a scale converter spreadsheet. Let's zip to that really quick. So my output 1 inch equals 60 feet. And that's going to give me a scale conversion factor. And this typically, this column I would use from Revit to MakerBot. But we're going to use the same number because, again, Revit and FormIt are both going to use convention as 1 foot represents 1 on the Cartesian coordinate axis system. So essentially, this takes into account, if I look at this number, B2 right here, and it's going to scale it up by a factor of 304.8. And that conversion factor is that idea of 1 foot equals 304.8 millimeters. So that's how we're getting that sort of conversion factor right here. So we're scaling it down in terms of getting this 1 inch to 60 feet, and then we're multiplying that by the 304.8, which is the conversion factor from feet to millimeters, or how many millimeters are in 1 foot. Sorry, it's a lot of math, a lot of words. Um, but going through this and having this really good process, knowing what it's going to do each time is really helpful. Okay, so we're going to do 42.32% as a conversion factor right here in terms of my scale. So I'm going to type this in as 42.32%, enter. Now I know that this model is at my 1 to 60 scale. Okay, so I know I've got a little bit of detail in here, windows, some awnings, some things like that. I know I'm going to lose a little bit of that because this is small. There's my entire build volume. This is kind of a little bitty guy. This is sort of Lego brick sized, to put it in context. So let's go to my settings. I know for the MakerBot, for architectural work, typically I want my quality set on low. Low is still going to give me really good crisp edges. What it's changing is my layer height. So if I go to high, you see the thing that's changing is I'm going to a 0.1 millimeter height per layer. And for architecture, as long as I have fairly smooth sides, that stacking is not going to be noticeable. It's not going to be detracting in terms of my quality. And I get a pretty big time saving in terms of how this works. Next, I know I'm printing in PLA on the Replicator 2 is what we're using in this particular case. No heated bed plate on that. So I am always going to print with a raft. And a raft, we'll look at what that is here in just a second. The raft is going to add print time, but in terms of preventing failures, it's totally worth it. Next, as you get clever in terms of printing these out, you can start reducing the infill amount, but a good beginning point is a 10% infill. And on our preview, we'll take a look at what that infill is as well, but it's essentially what's going to happen inside of this volume. So let's go ahead and hit OK and then preview. So it's going to take 18 minutes to print this. You can see we're definitely losing some detail around the windows, things like that, but if I scale that up, I'm going to have that detail there. And in terms of my virtual presentation, it's nice to have that detail there. Again, it's always about balance. If I start moving this slider down, I'm going to start seeing my different layers. So you can see this sort of hexagonal infill pattern. That's at 10%. It's at 10% infill. And then this is going to continue to move down. Also, you can see right here, I have this overhang, and I know that that's going to cause a little bit of a problem, but it's so slight that I'm not terribly worried about it. I think we should be okay. I'll probably get a couple of pieces of spaghetti right here, and that's just sort of a draping that happens whenever there's nothing underneath this. But I can deal with that. I can sort of snap those off. It shouldn't be something that's going to be terrible in terms of the disruption of the print. And then the last couple of layers are the rafts. So this is the first layer that gets put down, and then the entire file builds up just like that. So everything looks good. This is pretty much what you see is what you get kind of interface. If you see something weird, like, well, there are some weird things, like this little gap right here, that gap is going to be there. And that might be something that if I'm completely unsatisfied with that in terms of my 3D print, I don't recall that as something being in the physical model. That might be something I need to go back and change. And I'm not quite getting the in and out correctly interpreted by the 3D printer on these windows. So again, if I think that's something that's going to be a deterrent, I might want to fix that as well. So from here, I'm simply going to hit export, and I'm going to save this directly to my hard drive, and then I'll copy it over to the SD card to use in the printer. And let's go similar process, but we have one other 3D printer that we like to use a lot, and that's the Taz 5 from Lulzbot. And so let's go over to Cura, which is the interface for the Lulzbot. So again, really similar process. I'm going to go load model. There's 1828 main STL. I need to select my model and scale it again. Scale factor was 42.32. So it's not a percentage base here, it's numerically based. So it will be 0.4232, enter. And again, that's going to scale everything uniformly. Okay. Now it's doing the layering and the slicing in real time in Cura. There's no sort of preview. I can simply go here and look at layers, and I get the same kind of thing with the toolpath. So I can see exactly what's going to happen. Really similar setup, slightly different infill pattern. The next thing that I need to do is I need to go in and load a profile for this. So where we were printing with PLA on the Rep 2, we're going to be printing with a polyester filament called Engine on the Lulzbot. And so I want to load a profile for that. So I'm going to come to Expert first and make sure that I'm on full settings. And then I'm going to go to File, and I'm going to load, or excuse me, open profile. So we'll go to my drive, Cura, my profiles, and I'm going to load up Detail Engine. And so that's something I can get off of Lulzbot's website. And this is essentially going to establish my layer height, my speed, my temperatures. Well, actually, it's not doing temperatures. Okay, that's kind of an important thing. We'll cover that in just a second. But it's going to get the basics of that put together for me. So I know, again, my layer height, that is how many levels I have printing. And so this is a 22-minute print, which is really just fine. You know, there's not a lot of surface area. I could raise that, just like on the Rep 2, I could raise that to about a 0.3. And you can see I'm saving some time, but not a lot. It's such a small print that I'm pretty much okay with keeping that at that 0.18. That was the default. Or too many decimals there. 0.18, which I believe was the default. So we'll leave that in for right now. Again, not a big difference in print time. If this was a larger print, you would see a dramatic difference in terms of that dropping, setting that to 0.3 for an architectural kind of model. So a couple of other quick things. The printing temperature, that's the temperature of the nozzle. We need that set to 235. The bed, so this has the TAS5 has a heated bed plate on it, which is going to help that first layer adhere. So we want to go ahead and set that to 85. And then all that we need to do is click Save G-Code. Same thing. I'm saving this directly to my folder. This will be ready to write to the SD card 1828 main as a G-code file. Okay, that's pretty much it. The next thing is really just getting in front of the hardware and learning how to run the 3D printers themselves.